Yes, sir.
Yes, sir.
Okay, then after the revision now, let's move forward. Reaction of primary aliphatic amines with the nitrous acid. Nitrous acid, if you look at this, nitrous acid is prepared in situ from the sodium nitrite NaNO2 and HCl. So here you can understand if you have NaNO2, if you allow it to react with HCl, it simply gives us HNO2, which is this HNO2, which is known as the nitrous acid. And this nitrous acid is prepared by the reaction of NaNO2 and HCl in situ. In situ means during the reactions. Primary aliphatic amines react with nitrous acid to form aliphatic diazonium salt, which being unstable liberate the nitrogen gas quantitatively and also produce the alcohol. So this is how we understand, my dear students. Uh, Quantitative evolution of nitrogen is used in the estimation of amino acids and proteins. So please look at this reaction first. You can see that any primary amine reacts with HNO3, sorry, it is HNO2, which is actually the NaNO2 and HCl. 2 gives us the Rn2 plus and Cl minus, which ultimately, when reacts with water, it gives us the alcohol ROH, N2 and HCl. This nitrogen gas, which is produced by this or which is produced in this reaction, is used to estimate the amino acid present in the protein. So amino acids present in the protein have primary amine hopefully, and that is why this particular method is used for the estimation of amino acids into the proteins. So on the base of this nitrogen produced, we can estimate the amino acids present into the proteins. Now, let us see some example. If you have methanamine, CH3NH2, it reacts with NaNO2 and HCl and water, it gives us methanol. If you have ethanamine, it gives us ethanol. So this is how any amine can be easily converted to the required acid by this particular, required alcohol by this particular reactions. Now, students, we want to study about the reactions which is known as the diazotization. So here we have a reaction which is known as the diazotization reaction. When a primary aromatic amine dissolves or suspended in cold aqueous mineral acid like HCl is treated with sodium nitrate, a diazonium salt is formed. This is what we have studied even during our chapter known as the haloalkanes and haloarenes. It's just a revision for you. So aniline, when it reacts with NaNO2 and HCl, it produces benzene diazonium salt. Then, my dear students, we want to study about a very important reaction which is known as the carbylamine reactions. This reaction also we have studied while we were solving the exercise of chapter haloalkanes and haloarenes, and this is also the revision for you. Let us look at the carbylamine reactions. Aliphatic and aromatic primary amines on heating with chloroform and ethanolic potassium hydroxide forms isocyanides or carbylamines, which are foul smelling substances. So, we have either aliphatic or aromatic primary amine. So, we can have CH3NH2 or aniline that reacts in the presence of this is chloroform and this is ethanolic KOH. So, they reacts with the chloroform and ethanolic KOH. They produces the isocyanide. So, they can produce the aliphatic isocyanide like from methylamine to methyl isocyanide, and from aniline they produce the phenyl isocyanide. These isocyanides, which are produced in these reactions, they are foul smelling substances. Their smell is not so good, and we can easily identify their smell. And as they are foul smelling substances, this reaction is used to detect the primary amine by this smell. So methyl isocyanide and phenyl isocyanide are foul smelling substances, and a very important point that secondary and tertiary amines do not show these reactions. So when you want to separate, when you want to separately see, observe the primary amine and the secondary amine, when you want to separate or when you want to identify a primary amine that is different from the secondary and tertiary amines, we use this carbylamine reaction because this foul smelling substance isocyanate is given by only carbylamines, but not by the uh, only by the primary amines, but not by the secondary amines or tertiary amines. Now, my dear students, we want to study this reaction again, which we have studied into the haloalkanes and haloarenes. This benzene diazonium chloride is a very important intermediate for producing the many other reactions. So let us study the various reactions given by the benzene diazonium chloride. The first name reactions of benzene diazonium chloride is Sandmayer reactions. So my dear students, in Sandmayer reaction, we take the halogen or we apply halogen on the benzene ring with the help of the uh, uh, copper cuprous halide. So we can take Cu2Cl2 to get chlorobenzene. We can take Cu2Br2 to get bromobenzene. We can take CuCN to get cyanobenzene. So these chlorobenzene, bromobenzene or cyanobenzene, which are produced by the Sandmayer reaction by using the copper salt of halogen or cyanide, and we get the chlorobenzene, bromobenzene, and cyanobenzene. Same way, chlorobenzene and bromobenzene can also be prepared by the another reaction which is known as the Gattermann reaction. In Gattermann reaction, my dear students, this cuprous salt we prepare in situ. So we allow copper and HCl or copper and HBI to react with it. That is why on this basis we get Cu2Cl2, and ultimately these copper halides are produced in situ to give chlorobenzene and bromobenzene when they react with the benzene diazonium salt. Even my dear students, when benzene diazonium salt is just allowed to react with or just shaken with the potassium iodide, we can easily get iodobenzene. So benzene diazonium chloride, when it is allowed to react with potassium iodide, it gives us the iodobenzene. Same way, my dear students, when benzene diazonium chloride is allowed to react with the uh, fluoroboric acid. The name of this compound is fluoroboric acid. Fluoroboric acid, which is the formula of this is HbF4. So this fluoroboric acid, when it reacts with the benzene diazonium chloride, it gives us the benzene diazonium fluoroboride, and this benzene diazonium fluoroboride on heating simply gives us the fluorobenzene. Same way, my dear students, when benzene diazonium chloride is allowed to react with the H3PO2 phosphorus acid in the presence of water, it gives us benzene. Benzene diazonium chloride, when reacts with ethanol, it also gives us benzene. So, my dear students, benzene diazonium chloride on reaction with H3PO2 or on reaction with ethanol gives us benzene. So, we can easily prepare benzene from the benzene diazonium chloride. We can even prepare phenol from the benzene diazonium chloride. We just prepare phenol from the benzene diazonium chloride by the reaction of water. So when benzene diazonium chloride reacts with water, it gives us phenol. When benzene diazonium chloride reacts with H3PO2 and ethanol, it gives us benzene. Same way, my dear students, if we want to get the nitrobenzene, we need to take benzene diazonium chloride and allow it to the reaction with the HbF4. This HbF4 will give us the benzene diazonium fluoro um, bromoben, benzene diazonium fluoroboride. This benzene diazonium fluoroboride, when it reacts with NaNO2, that is NaNO2 plus HC, which simply reacts with NaNO2. This NaNO2 will gives us the nitrobenzene finally. So you can see that such a huge amount of products we can produce. Now, my dear students, when this benzene diazonium chloride reacts with some of the compound, they gives us dyes. So you can see here that we can get an orange dye and we can get an yellow dye. So when benzene diazonium chloride reacts with the aniline, it gives us the para-aminoazobenzene, which is an yellow dye. Remember, benzene diazonium chloride, when it reacts with aniline, it gives us the para-amino azobenzene, which is a yellow dye. You can see that this is the part of the benzene diazonium chloride, and this is the part of the benzene diazonium chloride, because both N are included in it, and this is the part of the aniline. Just aniline comes and combine with the nitrogen of diazonium chloride, and we get this reaction. Same way, my dear students, when this benzene diazonium chloride reacts with phenol, same way, this is the part of the benzene diazonium chloride. Just phenol combined with this nitrogen, just phenol combined with this nitrogen, and this is how, my dear student, not this side, but from the opposite side, you can easily understand that this side is bonded with the phenyl, and this is how we get para-hydroxyazobenzene. This para-hydroxyazobenzene is also an orange dye. So when either phenol or aniline reacts with the benzene diazonium chloride, they gives us the uh, yellow dye and orange dye, or they gives us the dye by coupling themselves with the benzene diazonium chloride, and that is why these two reactions are known as the coupling reactions. They are wonderful tests to find out whether the given amine is primary amine or not, because primary amine, when undergoes the diazotization, it gives us the benzene diazonium chloride, and then if it is allowed to react with aniline or phenol, it gives us the dye. So this coupling reaction is also the reaction to identify the presence of aniline, or this is how we can uh, uh, simply understand the reactions of aniline, or we can separate, or we can easily understand how we can discriminate aniline from the other compound. Now, my dear students, we want to study about the electrophilic substitution reactions of these compounds. So first we want to study about bromination. The main problem encountered during the electrophilic substitution reaction of aromatic amine is that of their very high reactivity. So these aromatic amines, like aniline, they are highly reactive for the electrophilic substitution reaction. Substitution occurs at both ortho and para position. So aniline is orthopara, or NH2 group is orthopara directing, and that is why the substitution takes place at both the places, ortho and para position. If we want to prepare the mono-substituted aniline derivative, we will have to follow the another method. So first we need to study about the bromination, that if we have aniline and we want to do bromination, this aniline is allowed to react with bromine water. When this aniline is allowed to react with the bromine water at room temperature, my dear students, bromine water is nothing but bromine dissolved in water. We get a 2,4,6 tribromoaniline. So we all, like, instead of getting the ortho or para product, we directly get the tri-substituted aniline, which is known as the 2,4,6 tribromoaniline. Now we want to produce the aniline either in the form of the, suppose we want to produce the 4-bromoaniline or para-bromoaniline. So we have studied in the last period, my dear students, that if we have NHCOCH3, this NHCOCH3 has got its capacity to deactivate the benzene ring, and that is why it decreases the activity of the benzene ring when it comes to the activating the benzene ring. So instead of only simple NH2 group, this NHCOCH3 this NHCOCH3 group actually decreases the activity of the benzene ring for the electrophilic substitution reactions. So for that, this aniline first has to allow it to react with the acetic anhydride or any anhydride in the presence of pyridine, so that we can get N-phenyl ethanamide, which is known as the acetanilide. This acetanilide, when it is allowed to react with the bromine water in the presence of CH3COOH, acetic acid, we get para-bromoacetanilide. Now, this acetyl NHCOCH3 group can be simply removed by the process of hydrolysis, and thus this para bromoacetinylide, when it is allowed to react or when it undergoes the hydrolysis, we get para amino or para bromoaniline. So this is how, my dear students, instead of directly getting 2,4,6 tribromoaniline, we can produce this para-bromoaniline by using first the acetylation and then by allowing the bromination, so that we get monobromobenzene. So this is the wonderful reactions that we should remember. Same kind of thing we can understand in this case also, that this NHCOCH3 makes the deactivation of the benzene ring for the electrophilic substitution reactions. Now let us study about the nitration of, of aniline. So aniline, when undergoes the nitration, it gives us the three product: para-nitroaniline, meta-nitroaniline and ortho-nitroaniline. Let us study about this. Direct nitration of aniline yields terry-oxidation products. Remember, direct nitration of aniline yields terry-oxidation products. In addition to nitro derivatives, in a strongly acidic medium, aniline is protonated to form aluminium ion. Now, what is terry-acidic products? So, generally, amino group is ortho-para-directing. So we should get the para-nitroaniline and ortho-nitroaniline, and para-nitroaniline should be the major product. But my dear students, apart from this, approximately 47% of meta-nitroaniline is also produced during these reactions. These kind of products are considered as a terry product. That means they are not the expected products. These products takes place because of the presence of the anilinium ion. Now what happens in strongly acidic medium? We are using nitric acid, we are using sulfuric acid in this reaction. So when we use nitric acid or sulfuric acid, generally the medium becomes strong acidic. So in this strong acidic medium, aniline is protonated to form aluminium ion. So my dear students, this aniline, which is benzene on NH2, when it reacts with the H plus, it produces anilinium ion, that is your NH3 plus. This is how it really works, that when this aniline reacts with the H plus, it gives us the anilinium ion. This anilinium ion is meta-directing in nature. So this anilinium ion undergoes the nitration, and when this anilinium ion undergoes the nitration, it gives us the meta-nitroaniline. So this is how, my dear student, instead of the para-nitroaniline and ortho-nitroaniline, meta-nitroaniline is also produced. And as the formation of anilinium ion is very easy, it gives us almost 47% of the meta-nitroaniline as a product. So sometime you are asked into the exam that why do we get meta-nitroaniline during the nitration of aniline? The reason is, in the acidic medium, aniline is transferred or converted into anilinium ion. Anilinium ion is meta-directing, and that is why we get 47% of meta-nitroaniline. Anilinium ion is meta-directing, so we get 47% of meta-nitroaniline. However, by protecting the NH2 group by acetylation reaction, now again we can avoid getting the meta-nitroaniline as a product. However, by protecting the aniline by the acetylation reaction with acetic anhydride, the nitration reaction can be controlled and para-nitroaniline can also be obtained as a product. So once again, my dear students, this aniline is allowed to react with the acetic anhydride and pyridine to get acetinylide. This acetinylide, when undergoes the nitration with the nitric acid and sulfuric acid at 288 Kelvin temperature, we get para-nitroacetinylide, and on hydrolysis, this acetinylide or NHCOCH3 group simply gives us the NH2 group, and this is how we get para-nitroaniline. So my dear students, this is how we understand the nitration of aniline. Now dear students, we want to study about the next reaction, which is known as the sulfonation of aniline. We want to do the sulfonation of aniline. So to do the sulfonation of aniline, first aniline is allowed to react with the H2SO4. It should be concentrated H2SO4. So my dear students, sometime for sulfonation, H2S2O7 is also used, which is known as the oleum. So this aniline is allowed to react with the H2 oleum or H2S2O7. It gives us the anilinium hydrogen sulfate. So this NH2 is simply converted to NH3HSO4. That means H2SO4 gives one its hydrogen to N, and thus it gives us NH3HSO4. This anilinium hydrogen sulfate on heating with at 453 to 473 Kelvin gives us sulfonilic acid. That means this NH3HSO4 is simply turned into NH2 group. And this sulfonilic acid is a Zwitter ion. This hydrogen, there is rearrangement. Please understand this. This is the kind of reaction which is known as the rearrangement. So there is a rearrangement of hydrogen. The hydrogen present into the SO3H group simply turns and go to the NH3 group and make NH3 plus ion, and this SO3H group turns out to be SO3 ion. So both positive and negative charge simultaneously present into this ion, and such ions are known as the Zwitter ion. So what is Zwitter ion? Zwitter ion is a kind of ion in which both the negative and positive charge simultaneously remains present. And this is how, my dear students, we study about almost all the electrophilic substitution reactions of aniline. Which substitution? So aniline generally gives nitration, bromination, sulfonation kind of reactions. But there is one very important electrophilic substitution reaction that we have not discussed with the in the case of the aniline. What is the reason? Let us find out that why we did not discuss a very important reactions which is known as the Friedel-Crafts reactions. So why we did not discuss about the Friedel-Crafts reaction of aniline, that is what we want to study here. So on your screen, my dear students, I have tried to show you the question which is written here. What is the question? Let's have a look to this. Why aniline does not undergo Friedel-Crafts reaction? What is the reason that the aniline does not undergo the Friedel-Crafts reactions? Aniline does not undergo the Friedel-Crafts alkylation or acylation due to the salt formation with the anilinium chloride. The Lewis acid, which is used for, so if you have aniline, the Lewis acid, which is used as a catalyst due to this, nitrogen of aniline acquires a positive charge and hence act as a strong deactivating group for the further reaction. Let me explain it to you, my dear students. For the Friedel-Crafts reaction, we generally use anhydrous AlCl3. This anhydrous AlCl3, when it combines with the aniline C6H5 NH2, it forms a salt, that is C6H5 NH plus and HAlCl3H minus. So my dear students, here what happens that due to the presence of the electron present on nitrogen, here there is a salt formed between C6H5 and AlCl3, and here this hydrogen, this nitrogen get positive charge and this AlCl3 get negative charge. So the kind of salt which is formed over here in which nitrogen get positive charge makes this two makes the attack of the electrophiles on benzene ring not possible, or it decreases the activity of benzene ring for the electrophilic substitution reaction, and this is how the positive charge present on the nitrogen makes the Friedel-Crafts alkylation or Friedel-Crafts acylation not possible for the benzene. Let me read now the answer, you will understand it better. Aniline does not undergo Friedel-Crafts alkylation or acylation due to the salt formation with aluminium chloride. The Lewis acid, which is used as a catalyst due to this nitrogen, the Lewis acid which used as a catalyst due to the nitrogen of aniline acquires positive charge and hence act as a strong deactivating group for the further reactions. So my dear students, during the Friedel-Crafts reaction, due to the salt formation with aluminium chloride, this reaction or the uh, Friedel-Crafts alkylation or Friedel-Crafts alkylation, acylation does not get possible for this aniline, and that is why aniline does not undergo Friedel-Crafts alkylation or Friedel-Crafts acylation, or aniline does not give any kind of Friedel-Crafts reactions. Now, my dear students, we want to study a very important reactions which is known as the acylation. So let us pay attention to the acylation reactions. Aliphatic and aromatic primary and secondary amines react with acid chloride, anhydrides, and esters by nucleophilic substitution reaction. This reaction is known as acylation. Once again, aliphatic or aromatic primary and secondary amines reacts with the acid chloride, that is RCOCl, anhydrides, that is RCO twice into O, and esters, that is RCOOR, by nucleophilic substitution reaction. This reaction is known as the acylation. You can consider this reaction as a replacement of hydrogen atom of NH2 or NH group by the acyl group. This acyl group is CH3 group, which is known as the acyl group, and this acyl group replaces this hydrogen from the NH2 group or NH group. The product obtained by the acylation reaction are known as amides. So we get CONH2 formed by this reaction. The reaction is carried out in the presence of a base stronger than the amides. So this base which we use, which is stronger than the amine, is pyridine, which removes the HCl so formed and shifts the equilibrium towards the right side. This HCl, my dear students, is removed by this base. So remember that this reaction is possible only in case of the primary and secondary amine. Tertiary amine does not give this reaction. Reaction of ethanamine with ethanoyl chloride. So here you have the ethanamine. This attacks on the ethanoyl chloride. What is your ethanol chloride? It is actually CH3COCl. So this is CH3, this is CO and Cl. There is an attack of the electron of nitrogen on the carbonyl carbon. So the electron from double bond goes on oxygen, and thus there is a bond formed between the nitrogen and carbon of the acyl chloride. This bond which are formed here makes the acyl group of ethanol chloride or acetyl chloride to be bonded with the amine, and thus this group which has chlorine also present as an ethanol chloride, this chlorine removes this molecule, then the hydrogen from amine also removes itself from the molecule, and finally we get the product of the acylation. The product in case of the ethanamine we get is known as the N-ethyl ethanamine. So you can see that is a ethyl group bonded to the nitrogen. So it is N-ethyl and two carbon present. So it is ethanamide. CONH2 group is also present, and that is why it is known as amide, my dear students. CONH group is present, that is why it is known as amide. So it is N-ethyl ethanamide because there are two carbon present over here. Same way, let us see the other or further reactions. Acetylation of N-ethyl ethanamine using ethanoyl chloride. So you have this compound N-ethyl ethanamine. This is N-ethyl part and this is ethanamine, which is allowed to react with the acid chloride CH3COCl in the presence of base. You can expect this carbon to be bonded with this nitrogen. This chlorine will be removed easily This chlorine will be removed easily and this hydrogen will be also removed, which produces HCl, and this bond is simply bonded to it. So here you can see that this is NCO group. So again it is a amide. And what type of amide? It has, this is the amide which has two ethyl group bonded with nitrogen. So it is N diethyl. And as there are two carbon here, we call it ethanamide. So this is how the acetylation takes place. Next reaction, my dear students, acetylation of aniline using the ethanoic anhydride. So this is your aniline, benzene, C6H5NH2. Then you have the ethanoic anhydride. Now, my dear students, instead of chlorine here, we have this part available. So this part, that is CH3COO minus, takes the negative charge as the chlorine takes the negative charge. This hydrogen is being removed from from the amine. This hydrogen is removed. This hydrogen and this part make CH3COOH, which is an acetic acid, and simply there is a bond between the carbon and nitrogen. So this carbon and nitrogen get bonded, and then we have CH3 group. So here you can see that this carbon and nitrogen are being bonded to give us the amide. This nitrogen is still bonded with the phenyl group, so it is N-phenyl. As we have two carbon here, the product name is N-phenyl ethanamide, which is also known as the acetanilide. Now, my dear students, we want to understand the benzoylation. So, in all this reaction, my dear students, we have used the attacking reagent as CH3COCl or CH3CO twice into O. Now we want to use the benzyl chloride C6H5COCl as a attacking reagent, and that is why this kind of reaction is known as the benzoylation. Initially, it was called acetylation because acetyl group was involved as an attacking reagent, but now we have C6H5CO group, or we use the C6H5COCl benzoyl chloride for the attack. This reaction is known as the benzoylation. So let us understand the benzoylation reaction, my dear students. If we have methanamine and if benzoyl chloride attacks on it, this nitrogen is get bonded with this chlorine and this hydrogen makes HCl and they are removed, and this is how we get CH3NHCOC6H5, which is known as the N-methyl benzamide. So here the product, instead of the acetamide, ethanamide, now we will call it benzamide. Same way, my dear students, if we take aniline and benzoyl chloride, we will get N-phenyl benzamide. Because with nitrogen, phenyl group is present, so we will call it N-phenyl benzamide. This acetylation, my dear students, is a very important reaction, and many times there are many questions asked from this acetylation reactions. So please learn it well. Now let's move and study a few of the examples so that we get a good revision and we understand the concept well. Let us revise the concept. Complete the following acid-base reactions and name the product. CH3, CH2, CH2, NH2 and HCl. We know that when any acid reacts with amine, it produces the salt, and this is how the N-propyl ammonium chloride salt is produced. Simply HCl is being added to this particular amine. Now we have the next reaction. C2H5 thrice N and HCl. Again, this HCl is being easily added and it gives us the trimethyl ammonium chloride salt. Now the next question. Write the reaction of final alkylation product of aniline with excess of methyl iodide in the presence of sodium carbonate solution. You can see, my dear students, it's a very interesting reaction. Aniline reacts with the methyl iodide to form N dimethyl aniline. You can see that first aniline, when it reacts with methyl iodide, one CH3 group is bonded. On second mole of methyl iodide will gives us N dimethyl aniline. So it is nothing but the ammonolysis with excess of methyl iodide in the presence of Na2CO3 solution. N dimethyl produce N trimethyl carbonate. Let us look at the product which is known as the N dimethyl NN trimethyl carbonate. So this N dimethyl aniline in the presence of CH3I, it gives trimethyl aniline, that is NN trimethyl salt. So here we are using sodium carbonate, and that is why it can be NN trimethyl sodium carbon. So this positive ion, when reacts with the presence of the 2 iodine and Na2CO3, it gives us the NN trimethyl aniline carbonate and 2 sodium iodine. So please learn these reactions because it may be asked into the exam. Write the importance of diazonium salt in the synthetic organic compound. For the introduction of fluorine, chlorine, bromine, iodine, cyano,